Notice, and this is a typical copyright. We continue with mathematics syllabus for CSEC, which became effective in May-June 2018. As of January 2026, the syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to this CSEC level math exam is to split the exam into two parts. As it relates to the current structure or format of the CSEC math examination, there is a paper 1 which runs for 1 hour and 30 minutes, and that paper consists of 60 multiple choice items from all sections of the syllabus as outlined below. Paper 2, which runs for 2 hours 40 minutes, consists of 10 compulsory structure type questions from all sections of the syllabus. There will be no choice. All sections will be tested, as I said, with compulsory questions. Paper 3-1 or 031. If you are in school, this is better known as a school-based assessment, where your teacher will give you some kind of project to investigate, collect data, and then analyze the data if you are in school. If you are not in school and you are writing this exam as a private candidate, then you would write 032, which is alternative to this paper up here. It runs for 1 hour. Instead of collecting your own data, you will be given data and asked to do statistical analyses on the given data. As it relates to the marks and the profiles, there is a knowledge profile, a comprehension profile, and a reasoning profile. From paper 1, 18 questions or 18 marks will be based on knowledge, 24 on comprehension, and 18 questions or 18 marks from reasoning, which would give you 60 marks from the 60 questions, which will have a weight of 30% of your final grade, and so on, paper 2, paper 3. Total 200 marks, which will be expressed as a percentage, and that will determine your final grade. As it relates to the sections of the syllabus and what videos have been done so far, section 1, 2, and 3, all 51 of those videos have been done and published in their entirety on YouTube. From section 4, 5, 6, and 7, all of those have been done, and some of these videos have been published on YouTube in their entirety. 5 from section 4 out of 17, 5 from section 5 out of 18, 7 from section 6 out of 22, 9 from 26 from section 7. We are now at section 8, geometry and trigonometry, and this is the 22nd of 26 videos from this section. Of course, once we finish with that section, there is still section 9 to do, vectors and matrices, and this schedule may have to be pushed back a little. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Still on section 1, number theory and computation, I have divided this section 1 into 33 videos, and they are all available on YouTube in their entirety, as I said before. But this was done specifically as section 1 forms the foundation on which the rest of the syllabus is based. How well you can handle this section, section 1, will predict how well you will be able to do the rest of the syllabus. If you're having problems with these, you will not be able to do the rest of the syllabus well. Here is a reminder: if you plan to write this CSEC exam, you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Still in section 1, number theory and computation. Most of these videos are even applicable in primary schools, that is from section 1, where the students themselves can look at the videos either before they come to class to deal with that topic or after as reinforcements. Teachers can use them in the inverted classroom, and specifically parents who may not feel comfortable teaching their children these math over here that you see, the parents can get a lot of help here. For example, if you consider this blue box here, let me expand it. Video 6, remember we are still in section 1 of the syllabus, talks about addition, subtraction, multiplication, and division of whole numbers. That is work done in grade 3 in the primary school. Video 7 deals with addition, subtraction, multiplication, and division of decimals. Work done in grade 4. Video 8, addition and subtraction of fractions, and video 9, multiplication and division of fractions. Work done in grade 5 and 6. And you have the rest of this section 1, which is essentially work that should be done in the primary school, like LCM and HCF and so on. Remember, there are 33 such videos in section 1 from the CSEC syllabus. If you are looking at this video, you are looking at the channel ROEL 922. If you rearrange it in playlists, you will notice there are a number of playlists, but the one I am talking about right now is this one here, which is section 1. As I said, most, if not all, of section 1 is work done in the primary schools. Don't be misled by the title, CSEC Mathematics, section 1, Number Theory and Computation. It is not as difficult as it sounds. Section 2, Consumer Arithmetic. All 12 of these videos from this section have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, Measurement. Some of these have been published on YouTube in their entirety, as indicated here in yellow, the others partially. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, Statistics. Same principle. A number of these videos have been published on YouTube in their entirety, the others partially. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, Algebra. Same principle. These videos that you see indicated in yellow here have been published on YouTube in their entirety, and the others partially. Keep in mind that those that are partially published, then they deal with each of these objectives partially. For example, law of indices. Some of that has been done in this video, even though it is only partially published. And as I already pointed out, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 7, Relations, Functions, and Graphs. These 9 videos have been published on YouTube in their entirety, and the others partially. Again, please see directions in the description below for full access to those videos that are only partially published on YouTube. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these in its syllabus. From those, I would recommend these last 2 here, as seen on the next slide. since they form a very good 2-volume set of math textbooks that is quite adequate for the current and future proposed changes in the structure of the CSEC math exam. This is a picture of Volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi, and this is a picture of Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from Paper 2. It is extremely important that you become familiar with how CSEC sets its questions for Paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like, which is this. You would have to register first and subsequent to that, sign in. Again, that is the URL. This URL will be listed in the description of this video below, so you can easily click on it and be redirected to this website. Another reminder that this formula sheet you see on the left here is provided for the CSEC math examination papers. It is also included in a full copy of the syllabus if you have such a copy. If you don't, then there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examinations for mathematics. And this is the below part of that same formula sheet. While you do not need to memorize these formulae here, you do need to know when and how to use them. As it relates to this specific objective, please note that this formula sheet has the trigonometric ratios defined on them. For example, sine theta is equal to opposite side over hypotenuse as it relates to this right triangle, and cosine and tan. So section 8, geometry and trigonometry. We have finished all the objectives on that page. And there's one objective on this page completed. There's one objective on this page completed. On this page, objectives 7 to 11, all of them have been completed. We have also completed objective 12, which was video 21. So we are now at objective 13, video 22. Just to summarize what we have been saying so far for this section, we have completed up to here 21 videos. From those, these have been published in their entirety, the others partially. So we are now here, video 22, 8_13. That's the objective we are doing right now. When this is finished, it will be published in its entirety. As it relates to the remaining 4 videos, this one more will be published in its entirety when it is finished, of course, and these other 3 partially. So from this section, 9 out of 26 videos would have been published in their entirety on YouTube. The rest partially. Please see directions in the description below to access the full videos for those that are partially published here. So as I said, we are here, video 22, and it says objective 8_13, define the trigonometric ratios of acute angles in a right triangle. And then the 3 that you are supposed to be able to define are sine, cosine, and tangent. Now note objective 15. Here we are defining them, making sure we understand what they are, and then in objective 15, we will apply the trigonometric ratios to solve problems. Apply trigonometric ratios to solve problems. So in this objective, we are not going to do much calculation. Remember this? It is part of the formula sheet given during the CSEC math examination. So you are given the definition, and up here, this objective says you are to be able to define them. So maybe this objective was part of the syllabus before it was decided to provide the formula sheet during the CSEC math examinations. Nevertheless, I will proceed with this objective just to make sure you understand the definitions, even though they may be here on the formula sheet. I just want to make sure you understand what they are saying. So we will still go through them. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So the objective is define the trigonometric ratios of acute angles in a right triangle. Now this is redundant because if it is a right triangle, the other two angles must both be acute. So the sine, the cosine, and the tangent. Just a reminder, if you have a right triangle like this or like this one over here, this is the right angle. The side opposite it is called the hypotenuse. Same thing here. The side opposite that right angle is called the hypotenuse. Note, in addition to the right angle in a right triangle, there are also two acute angles. These two angles here, that one and that one, they must be acute because their sum is 90. If this one is 90, and the sum of all the angles in a triangle is 180, then those two together must be 90. So each one must be less than 90. So as I said, this acute here is redundant. That's not needed. Of necessity, they will be acute. So that one is acute, this one is acute. Same thing goes here. That angle there is acute, this one here is acute. Because together, they will add up to give 90 degrees. So each one must be less than 90. So now let's deal with the sine. Now notice I put acute here in bracket. The sine of an acute angle in a right triangle is the ratio of the opposite side to the hypotenuse of the triangle. So if you look at this triangle here, if we are dealing with this angle here, this side is the opposite, and this side is the adjacent. Of course, that side there is the hypotenuse because it is opposite to this right angle. So the sine of this angle is the ratio of the opposite side to the hypotenuse, and I will explain what that means. Let's consider this triangle here. That's the hypotenuse because it is opposite the right angle. We will consider this angle here. It is 30 degrees. That is the opposite side. Now, if we consider the sine of 30, it will be the ratio of the opposite to the hypotenuse. So the sine of 30 will be the ratio of the opposite to the hypotenuse. It will be 0.5. So if you enter in your calculator 30 degrees and find the sine of it, you will get 0.5. But what does that 0.5 mean? It means that the opposite is 0.5 of whatever the hypotenuse is. It is half of the hypotenuse. That is what this 0.5 means. It is 0.5 of the hypotenuse. Now, if you take another upright like this, and you make a smaller right triangle, like that, this is now the opposite. This opposite here, at 30 degrees, will always be 0.5 of that triangle there, that ends here. And if you take another line like this green line, at 90 degrees, this opposite in relation to this triangle, this right triangle here, at 30 degrees will also be 0.5 of this hypotenuse here, from here to there. And even if you take another line here, at right angles, this red line will be 0.5 of whatever this part of that triangle is, which is the hypotenuse. So when you find the sine of 30 degrees and you get 0.5 for a right triangle, that means that the opposite is 0.5 of whatever the hypotenuse is. So let's take this blue triangle here now. Notice this angle is bigger than that 30. This opposite is the same, but now the hypotenuse is smaller than that yellow one up there. So if you find the sine of 45, which would be the ratio of the opposite to the hypotenuse, you will get a larger ratio because the hypotenuse is smaller. So if you find sine of 45, you will get 0.71, which means that this opposite is now 0.71 of whatever this hypotenuse is. It is much more than that 0.5 for that hypotenuse at 30 degrees. And if you make this angle even bigger, say 60 degrees, notice that now this opposite is very close to that hypotenuse. So we will get a ratio even larger than 0.71. So if you find sine of 60 degrees, we get 0.87. So now at 60 degrees, this red opposite here is 0.87 of what that red hypotenuse is. Let us say the opposite is 10. And this hypotenuse, this yellow hypotenuse here is 20. If you divide the opposite by the hypotenuse, you will get 0.5, which is that, at 30 degrees. Let us say now, for this blue triangle here, we will keep the opposite the same as 10, but we will now make the hypotenuse 14 because it is shorter than that 20. So it is 14. So if you divide 10 by 14, you get 0.71. At 45 degrees, the ratio of the opposite to the hypotenuse is 0.71, which is what we had here. And then when we come to 60 degrees, it is 0.87. This hypotenuse here is 11.5 centimeters when this is 10. Notice that 10 is very close to this 11.5. And so it is actually 0.87 of the hypotenuse. So if you find the sine of an angle, you are finding the ratio of the opposite to the hypotenuse. The ratio. Notice 10 was constant for all the opposite, and you keep dividing by smaller and smaller hypotenuse. So if you keep dividing 10 by smaller and smaller hypotenuse, then the ratio will get larger as you go along. Let's look at these in a table with more angles instead of just these 3 angles. So let's take many more angles. If you find a sine of 15 instead of 30, then the opposite is 0.26 of whatever the hypotenuse is. If you find a sine of 30, it is 0.5, which is half of the hypotenuse. If you find the sine at 50, it is 0.77 of the hypotenuse. Now, if the hypotenuse is 24 centimeters at 30 degrees, then the opposite will be 0.5 of that. At 30 degrees, the sine is 0.5. So if this hypotenuse is 24 centimeters, this will be 0.5 of whatever the hypotenuse is, which would be 12 centimeters. Or conversely, if the opposite is 14 centimeters at the same 30 degrees, then the hypotenuse would be 14 divided by 0.5, which would give us 28 centimeters. The hypotenuse will be twice the opposite, or the opposite will be half of the hypotenuse. Now, this is what the sine of an angle means, is the ratio of the opposite to the hypotenuse. Also, if you know the opposite and hypotenuse, you can easily calculate the angle here. But more on calculation in objective 15 in this section. This is just to give you an idea of what we are talking about. We will deal with the calculation in objective 15. We are now at objective 13. Now let's talk about the cosine. This is from your syllabus. The cosine of an acute angle in a right triangle is the ratio of the adjacent side to the hypotenuse. So that is the hypotenuse. It has nothing to do with which angle we are talking about. That hypotenuse is always opposite the right angle. But if we are dealing with this angle here, the cosine of that angle is the ratio of the adjacent side to the hypotenuse. Previously, when we were dealing with sine, we were dealing with the opposite to hypotenuse. Now, for cosine, we are dealing with adjacent to hypotenuse. So let's consider this right triangle here. You already know that is the hypotenuse because it is opposite this right angle. We will consider this angle down here, 30 degrees. What is the side adjacent to it? This here. This is the adjacent side. And of course, that is the hypotenuse. If we find the cosine of 30 degrees, we are finding the ratio of this adjacent side to the hypotenuse. And notice it is 0.87. It is almost as long as the hypotenuse. Remember, we are not dealing with opposite, we are dealing with adjacent. So if we let the adjacent be 10 and the hypotenuse 11.5, if we divide 10 by 11.5, we will get 0.87. That is to say, at 30 degrees, the adjacent is 0.87 of whatever the hypotenuse is. So if the adjacent is 10, the hypotenuse would be 11.5. Let's change that angle and make it bigger. Notice we haven't changed this adjacent side. If we make this 45, then the cosine of 45 is adjacent over hypotenuse. Notice the hypotenuse gets longer. The adjacent remains the same. So the cosine of 45 is 0.71. In other words, this adjacent is now only 0.71 of that hypotenuse. So if this adjacent remains 10 and the hypotenuse becomes 14.1, it is longer than this 11.5 down here. And we divide those two, we will get 0.71. That is at 45 degrees. Now let's remove that 45 degrees and make this angle even bigger, like that. Notice the adjacent is still the same 10 we had up here. But now this hypotenuse is much larger. Let's say this angle is 60 degrees. If you find the cosine of 60 degrees in your calculator, you will get 0.5. That is to say, this adjacent side is 0.5 of whatever the hypotenuse is. Now remember, this is cosine, not sine. When we were dealing with opposite and hypotenuse, we are now dealing with adjacent and hypotenuse. So if this adjacent remains 10 and the hypotenuse is now much larger than those two, and those two, it is 20, you divide 10 by 20, you get 0.5. So this is what you mean by the cosine of an angle. Notice that the hypotenuse keeps getting larger and larger. The adjacent remains the same. So if you are dividing the same number by increasing numbers, then your answer will decrease. 0.87, 0.71, 0.50. Let's take a look at this in a table with more angles. So at 15 degrees, the adjacent is 0.97 of whatever the hypotenuse is. It's almost as long as the hypotenuse at 15 degrees. At 20 degrees, the adjacent is 0.94. Now, if you keep increasing these angles, say to 50 degrees, then this adjacent is 0.64 of whatever the hypotenuse is. And if you go to 60 degrees, as we just saw, this adjacent is 0.5 of whatever the hypotenuse is. So if this adjacent is 10, that hypotenuse will be 20. Or the other way around, if that hypotenuse is 20, the adjacent will be 10 at 60 degrees. At 80 degrees, the adjacent will be 0.17 of whatever the hypotenuse is. At 85 degrees, the adjacent will be 0.09 of whatever the hypotenuse is. By the time you get up to 90, we get to 0.00. So that the hypotenuse actually falls here. And you get, at 90 degrees, 0.00. So if the hypotenuse is 24 centimeters at 30 degrees, then the adjacent will be 24 times 0.87 at 30 degrees, 24 times 0.87, which would be 20.9 centimeters, which is almost 21. So when that is 24, this is 21, a little shorter. Or if the adjacent is 14 centimeters, at 30 degrees, the hypotenuse will be 14 divided by 0.87, which would give you 16.1 centimeters. So they are almost the same. The hypotenuse is a little longer. Also, if you know the adjacent and the hypotenuse, you can easily calculate this angle. But more on calculation in objective 15 in this same section. To summarize what we have done so far, the sine of an acute angle in a right triangle is the ratio of the opposite side to the hypotenuse, opposite to hypotenuse. And the cosine of an acute angle in a right triangle is the ratio of the adjacent to the hypotenuse. Adjacent to hypotenuse. Here is a table. The sine of 15 is 0.26, meaning that the opposite is 0.26 of the hypotenuse. Whereas the cosine of 15 is 0.97, meaning that the adjacent is 0.97 of the hypotenuse, almost as long as the hypotenuse. And you could go down the list like this. Note 1. As the angle increases, its sine also increases up to a maximum of 1.00 at 90 degrees. As this angle increases, the sine also increases up to 1.00. While its cosine decreases from a maximum of 1.00 at 0 to a minimum of 0.0 at 90 degrees. So this increases from a maximum of 1 and it decreases down to 0 as the angle increases. Also note 2, the sine of one angle is the cosine of its complement and vice versa. For example, take 30 degrees. The sine of 30 degrees is 0.5 and the cosine is 0.87. But what is the complement of 30? It is 60, which is this one down here. The 2 will add up to 90. Then notice now that the sine of 60 is 0.87, which is that over there. And the cosine of 60 is 0.5, which is that over there. That's one example. The next example is 40 and 50. Those two will add up to give you 90. They are complementary. Notice 0.64 here and 0.64 there, and 0.77 here and 0.77 there. And one more, 15 here. The complement of that is 75. Those two will add up to give you 90. The sine of 15 is 0.26, whereas the cosine of 75 is 0.26. And the cosine of 15 is 0.97, whereas the sine of 75 is 0.97. So, okay. Next, let's consider tangent trigonometric ratio. So we have looked at sine, we have looked at cosine. Not only have we defined them, but we now know what they mean. The tangent of an acute angle in a right triangle is the ratio of the opposite side to the adjacent side. So we are not talking about hypotenuse here. So you consider this triangle here. If we are dealing with that angle, we will be dealing with opposite to adjacent. The tangent of that angle is the ratio of the opposite to the adjacent. Now, sine theta was opposite to hypotenuse. That is to say, we were dealing with opposite here and hypotenuse there. Cosine theta, we were dealing with adjacent here and hypotenuse there. Now, in this case, tangent, we are not dealing with hypotenuse at all. We are dealing with opposite to adjacent, the ratio. So let's consider this right triangle here. If this is 30, now remember, we are not concerned about the hypotenuse. We are concerned about the opposite and the adjacent. That's the opposite. This is the adjacent. If we find the tangent of 30, we get 0.58. That means at 30 degrees in a right triangle, the opposite side is 0.58 as long as the adjacent side. The opposite side is 0.58 of the adjacent side. So if the opposite measures 10 centimeters, the adjacent side would be 17.2. So when you divide those two, you will get the ratio 0.58. So at 30 degrees, this opposite is 0.58 of whatever the adjacent is. If you take a different right triangle here, this opposite is 0.58 of that part of the triangle because that is the adjacent. And if you take another perpendicular here, that opposite is 0.58 of whatever this length here is because that length is now the adjacent. And if you take another perpendicular here, this opposite is 0.58 of from here to there, this adjacent, 0.58. Let's consider a larger angle, 45 degrees. Notice that this opposite here increases, whereas the adjacent remains the same. So if we find the tangent of 45 degrees, we get 1.00. What that means is that this opposite is exactly the same as the adjacent at 45 degrees. So if the opposite is 17.2, the adjacent is also 17.2. So that would give us 1. Remember, in the other two cases, we didn't pass 1. We went from 0 to 1 or from 1 to 0. Now, in this case, you will understand that if we make this angle larger, that this opposite will now be larger than the adjacent, and we will get a ratio greater than 1. So let us remove that 45 from there and take a larger angle like this. This angle is 60. Look carefully at this red opposite here and this adjacent. The adjacent did not change. And so what do we get? Tan 60 is 1.60. 1.73. So if the angle is 60 degrees and you find the tangent of that, the opposite side will be 1.73 times larger than the adjacent, almost 1.75 times as large as the adjacent. So it would be something like this, 29.8 divided by 17.2. Remember, this stays the same, and we get 1.73. This adjacent remains the same. We are dividing larger numbers by the same denominator, and so we will get larger answers. Let's look at this in a table with more angles. So if you find tan 15 and you get 0.27, that means that the opposite is a little more than a quarter of the adjacent. At 30 degrees, the opposite is almost 0.6 of the adjacent. At 45 degrees, the opposite is exactly equal to the adjacent. At 60 degrees, the opposite is nearly 1.75 times longer than the adjacent. At 80 degrees, the opposite is 5.67 times longer than the adjacent. At 85 degrees, the opposite is 11.4 times longer than the adjacent. And at 90 degrees, well, we have a very, very large number, 1.63 exponent positive 16, that is 163 with 14 zeros behind it. That's an extremely, extremely large number. Almost, technically, it should be infinite. Now, if the adjacent is 24 centimeters, that's this, at 30 degrees, then the opposite will be 0.58 of the adjacent, which would be 13.9 centimeters. Or if the opposite is 15 centimeters at 30 degrees, then the adjacent will be 15 divided by 0.58, which is 25.9 centimeters. In this case, you know the opposite, and we are calculating the adjacent. Also, if you know opposite and adjacent, you can easily calculate this angle here in a right triangle. But more of this calculation in objective 15. So we talked about sine, we talked about cosine, we talked about tangent. So sine, cosine, tangent. All you were supposed to be able to do for this objective is to define these trigonometric ratios. If we put all of them together like this, you can see what the situation is. These two are complementary. As I said, if you take 30 and 60, you will find that is 50, and this one down here is 50. That's for the sine and the cosine, or 0.87 and 0.87, sine and cosine. Tangent is not related to them. See, those two were using hypotenuse. Tangent is not using hypotenuse. Sine is using hypotenuse, cosine is using hypotenuse. Tangent is not using hypotenuse, it's using opposite to adjacent. So we can begin from very small here, go up to 1, pass 1, and go up to infinity. While there is a complementary relationship between sine and cosine, tan stands on its own. The sine of one angle is the cosine of its complement, and vice versa, as I just explained. By the way, CSEC does not require you to know to do this in Microsoft Excel, not even for IT, but there may be one or two students who want to know how I got those formulae in that spreadsheet. This is the formula. To get the sine of 15 degrees, I use equal sine, open, radian, open bracket, the cell there, which is B2, close bracket twice, and that would give me the sine of 15 degrees. The same thing for cosine and the same thing for tangent. Just in case one or two of the better students would like to know how I got those in Excel. So remember what I said. This is the below part of this sheet with the formula that is provided by CSEC for the math examination papers. Note, calculators are not allowed for paper 1. And while this objective requires you to define these, the definitions are there. I explained what the definitions are and what they mean. So define the trigonometric ratios of acute angles in a right triangle, sine, cosine, and tangent. And that brings us to the end of video 22 based on objective 13 in section 8. Is 0.58